Hello, and welcome to another episode of the WEM Video Academy. Today we are going to have a look at building an HTTP endpoint. HTTP endpoints are versatile entry points into your application for HTTP request-based services. They allow your application to serve as a provider of functionalities or data for third-party consumers. HTTP endpoints can be found near the bottom of the navigation tab in your modeler. HTTP endpoints may be used as an alternative to the HTTP exposure of exposed web services in the integration tab. However, there are various differences between the two. As far as HTTP exposure goes, web services exposed in WEM can only be consumed using POST requests. They have a fixed object-based input and output structure, and they can only return two different HTTP status codes, namely 200 and 500. In comparison, HTTP endpoints support every HTTP request method. It offers total freedom in composing the input and output structure and will send every desired HTTP status code. They do require a bit more knowledge of HTTP request handling though, so sit back and enjoy this video. Let's start by creating a new HTTP endpoint. Select the New HTTP Endpoint option from the three-dot context menu. This dialog will appear on your screen. The URL path will be the deep link URL providing access to your endpoint to consumers. The HTTP request method will allow to set the desired request method, the most common ones being the GET and POST request. The validation and initiation checks will be discussed at a later moment in this video. The OpenAPI documentation will allow access to a web page showing the total configuration of all of your endpoints in this project. The parameters are the true custom part of HTTP endpoints. Stay tuned for a detailed explanation in this video. Note that all of these properties define the conditions to which the incoming requests to your endpoint are bound. We will now discuss the various endpoint properties one by one. The URL path is the deep link into your HTTP endpoint. It's also a suffix to your application URL in both the staging and live runtimes. Please be aware that HTTP endpoints only work in the runtimes and not in preview. This means you will have to publish your project in order to make your endpoints work. The URL may contain two different dynamic portions. The URL parameter is an integral part of the endpoint URL. It is located in between the slashes that form the URL. A URL parameter is automatically added to the parameter list at the bottom of the dialog. The query parameter is not an integral part of the endpoint URL, but is added as a key value pair, behind a question mark or ampersand character in the URL extension. Query parameters are defined manually in the parameter list at the bottom of the dialog. After creation, both URL path and query string parameters can be bound to session fields in the data model. The HTTP request method refers to the list of documented HTTP request methods available in the HTTP specification online. Each method has its specific purposes. The two most common ones are the GET and the POST request. The GET request is used to obtain information from a web service. The request specification can only be sent in the form of URL queries, which are publicly accessible. A GET request returns an HTTP response object, a set of HTTP response headers, and an HTTP status code. The POST request can also be used to obtain information from a web service, but also to send information to a web service. The difference here is the presence of an HTTP request body that can be used to send information in plain text, form data, or structured objects such as JSON. The request body is not publicly accessible during the transmission of the request and can be used to send confidential data to the web service. Please refer to online sources for a specification of the other request methods. Onwards to some checkboxes. The Validate Parameters Automatically checkbox can be set to validate the parameters automatically. This means that in case of exceptions, for instance, a missing request body or a missing parameter value, the request will be cancelled automatically. The Initiate a WEM runtime session on first request checkbox can be used to link an incoming request to a user session. This is particularly useful when forwarding a request to a third-party service. For instance, a payment provider, and then return to the same session once the third-party process has finished. We know this as the common Return to Web Shop event. The pass form fields in a request body to JSON checkbox is used to convert a form-based request into a raw JSON request. The parsing process will attempt in the best possible way to convert the form field data into a JSON object. This can be used if the consumer can only send form-based requests, while the project is designed to receive JSON-based requests. The OpenAPI documentation is a web page listing the structure of the combined HTTP endpoints in your project. A custom deep link suffix to the documentation, OpenAPI, by default, can be submitted here together with a description. And now for the parameter list. The first button in the row allows to add query parameters. As explained earlier, query parameters can be added as an extension to the endpoint URL. In a GET request, they are typically used to submit extra details to the endpoint regarding the requested information. Request headers can be added to parse the headers of the incoming request and map them to fields in the data model. This is particularly useful for retrieving authentication information, as we will see later on in this video, but it can be used for many other purposes as well. Form fields can be defined to map key value pairs in a form-based request to fields in the data model. If your project allows, this method is preferred to the parseFormFields method discussed a few moments ago. Once we have composed a list of parameters of the 3 different types, we can set the required check for required parameters, and we can choose to have the parameters inherited by nested endpoints inside our endpoint. So far, we have been busy with exploring the many different properties that can be configured in an HTTP endpoint. Now it is time to explore what we can make the endpoint actually do. For this purpose, we need to look at the HTTP endpoint flowchart. The flowchart contains the logic of the endpoint. It is the flow being executed once a consumer sends a request to the endpoint. The flowchart can be accessed by double-clicking the endpoint or by selecting the option Open Flowchart from the Endpoint context menu. This is a sample from another endpoint. We will now build our own. An HTTP endpoint flowchart is quite similar to a regular action flowchart, such as the ones found in exposed web services. However, there is one notable difference. In an HTTP endpoint flowchart, the regular end node is replaced by a response node. The response node contains the output of the endpoint as well as the status code. Both the output and the status code can be chosen freely. This allows for a custom output format, for instance, form or JSON-based, and for a custom range of status codes, such as 200, 400, 403, or 503. You may refer to online sources for the accepted HTTP status codes as part of the REST standard. Let's start with a very simple response. Hello world. You sent the number plus the text in the URL path ID parameter. Don't forget to publish your project before testing your endpoint. Also, after every update of your endpoint configuration or flowchart. An easy way of testing web services is by using the free software Postman. This software can be downloaded from public download sites. It is a lightweight package that does not require installation but can be used directly after unzipping it. We will configure the request as follows. We will fill out the URL with a URL parameter, in this case 100. We will use an empty body. We will send the request. And we will see the response being received with the URL path ID value inside. We have now received the first proof of life of our new HTTP endpoint. Now we will make our endpoint a bit more dynamic. We will use a raw JSON body for sending a customer ID. We will expect the endpoint to return the customer details for that ID. If the customer ID is 0, the endpoint should return the first 10 customers in the list. For this purpose, we will use an import JSON node for reading the request body, followed by an export JSON node for returning the customer list. The import JSON node will read the JSON object in the HTTP request field and contain the mapping to the customer ID. The export JSON node will export the contents of the filtered customer list. The customer list filter will be this expression. It will either select the requested customer or the first 10 customers in the list if the customer ID is 0. The output of this export node will be stored in the HTTP response field. In the final step, the response node will return the JSON object in the HTTP response field. Let's connect the exits, publish our project again, and start our next test. Back in Postman, we can send several different requests, and we see the response appearing as expected. We can request either a single customer, or an array containing 10 customers, or an empty list in case of an invalid customer ID. Let's build some additional response types with associated status codes. 422, import error. This status code and output will be sent when the content of the HTTP request body cannot be passed because of some error in the request object. 404, not found error. This status code and output will be sent if the requested customer or customers cannot be found. For this purpose, we will check if the customer list filter has a value. 503, export error. This status code and output will be sent when the data requested in the HTTP request body cannot be exported for a technical reason. 200, success. This status code and output will remain unchanged and be sent if the request has been completed successfully. We will test these new status codes later on. An important topic to discuss when creating HTTP endpoints is authentication. You may know that exposed web services in WEM offer several different built-in forms of authentication, such as basic authentication or client certificates. HTTP endpoints do not provide standard authentication options. Like the other properties, the authentication method is fully custom and needs to be handled by the endpoint flowchart. HTTP request headers offer multiple ways of sending authentication information, such as basic authentication or bearer token authorization. These authentication methods are supported by defining the appropriate request header. Let's have a look at our sample HTTP endpoint again and assume we would like to secure our endpoint using basic authentication. For this purpose, we will first define the incoming authorization request header. Spell it with a Z. As per the HTTP specification, a basic authentication object is a base 64 encoding of the concatenation of a username and password separated by a colon and preceded by the word basic. Once we have defined and mapped the HTTP request header, we can read the content of the basic authentication object with an expression inside two separate calculated fields. First, we decode the base 64 object into a regular string, after having removed the basic prefix. Next, we split the object on the colon separation character. We then refer to the first and second split parts as the username and password. Now we can validate the calculated username and password and decide whether the consumer will get access to our endpoint. Should you require a higher level of security, you could require your consumer to encrypt the basic authentication object and decrypt it after reception. Once we have the decoding expression in place, we need to extend the flow. We will check two things. First, if a username-password combination has been provided by the consumer, and second, if the username-password combination is valid. The first check is done in this decision node using the hasValue function on both the calculated username and password. If the check fails, we exit into a 400 error, reporting that a username and password were not received. The second check is done in this decision node. Here we will do a simple literal check on two predefined username and password values. Of course, you can make this username-password check as dynamic as you would like. If the check fails, we exit into a 401 error, reporting that the combination of this username and password is not valid. Only if both checks pass, we will allow access to the logic of the flowchart. Let's do a final publication and test in Postman. We will first send the request without authentication, and we will receive the 400 error. The basic authentication can be configured in the Authorization tab. We will select Basic Auth from the drop-down and fill the username and password that we agreed upon. However, we will first send the request with an invalid username and we receive the 401 error as expected. We will now correct the authentication and then we will force an error in the request body by submitting an invalid customer ID value type. As expected, we received the 422 import error. And finally, in a last provocation attempt, we will now send the correct request for an invalid customer ID, and we receive the 404 error. Finally, we will put everything in place and we receive the customer details with a status code 200. We have now built a fully functioning and authenticated JSON-based HTTP endpoint. As an alternative, let's have a look at a form-based request instead of a JSON-based one. In Postman, we can choose between multi-part form data and the text only. Form URL encoded type. We will choose the latter and create a form field customer ID with a value 0. Sending this request will return an import error, since the HTTP request body does not contain a JSON object anymore, but just a simple form field and value. Let's explore the effect of using the checkbox pass form fields in request body to JSON. As we can see in the brief explanation underneath, the parsing process will return both the form field name and value in string format. That means we will have to make 2 changes. The import JSON node needs to accept a text type customer ID value instead of a numeric one. The customer list filter needs to be able to handle a text type customer ID reflected in this logic. We will replace the filter expression accordingly. After publication, we test the form-based request in Postman again, and we now see the same response as with the JSON-based request. The endpoint will now handle form-based requests, which is something you will not be able to do with exposed web services. Instead of using the pass checkbox, we could have also opted to use the customer ID form field in our flowchart directly. For a strictly form-based interface, that is the preferred method since it is easier and does not require parsing. The checkbox is only meant for handling form-based requests in an otherwise JSON-based environment. And that concludes our video. We hope you enjoyed it. Please leave your feedback in the comments below and share the video with your colleagues and friends. We hope to see you soon again in the WEM Video Academy.